Gyroscopic transport. In his vision for the future of urban transportation, gyroscopic transport Dahir Insat aims to completely alter the way people navigate through cities. These solar-powered disc-shaped cars use flywheels to float above traffic on stilts. Their multi-tier transportation system has the ability to lessen pollution and traffic jams. Travelers can anticipate either cramped subway-style seats or plush pods outfitted with sofas and televisions. Although the specific cost has not been made public, the idea's positive effects on the economy and the environment indicate that it may prove to be an economical choice for urban areas in the future. The design prioritizes user comfort and integration with urban settings, with the possibility of working in tandem with pedestrian spaces. This groundbreaking form of transportation is still in its early stages, but it has the potential to revolutionize urban transportation in a sustainable and efficient way. Renault Float, an innovative concept car that blends cutting-edge technology with a future design, is a vehicle that mixes two technologies. Due to its distinctive spherical shape, it is able to move in any direction without difficulty. The exterior of the car is constructed from a translucent material that can change color and transparency, providing a dynamic and adaptable appearance. On the inside, it features a roomy cabin that can be customized to preferences, with an emphasis on comfort and connectivity. The Float in Motion is a vehicle built for autonomous driving, outfitted with cutting-edge sensors and artificial intelligence to provide a ride that is both safe and efficient. It exemplifies Renault's vision for the future of urban mobility, which places an emphasis on user experience, flexibility, and environmental responsibility. The Flying Train by Dahir Insat is a futuristic transportation system conceived by the Russian engineering company Dahir Insat. This cutting-edge system combines elements of conventional rail travel with advanced technology. It comprises train-like pods suspended from overhead lines. Although the pods are designed to move at high speeds, they offer a quick and efficient alternative to traditional trains and urban transportation. With electric propulsion, the system claims to minimize traffic congestion and provide environmental benefits. Additionally, the elevated rails allow for minimal disruption to existing infrastructure, making it an adaptive and scalable solution for contemporary urban landscapes. The MG Maze concept car is designed to appeal to future motorists. MG created a futuristic take on city transportation, combining mobility and gaming in a whimsical way. This little two-seater is ideal for urban environments, showcasing its internal mechanisms for a dynamic look. The exterior features a transparent shell reminiscent of high-end gaming PCs. Instead of a conventional steering wheel, passengers can interact with the vehicle using their smartphones, thanks to cutting-edge UX/UI technology and floating seats. As a concept vehicle, the MG Maze explores ideas for the future of automotive technology and design. While it has no market value since it is not for sale, concept automobiles like the MG Maze often influence the creation of future production versions. Skyway technology presents numerous advantages, particularly its cost-effectiveness. One of the primary benefits is its considerably lower construction cost compared to traditional and advanced transit systems. For example, Skyway integrates innovative transport infrastructure at a fraction of the cost associated with more conventional systems. This involves significantly lower requirements for steel and reinforced concrete, optimizing material use while maintaining structural integrity. In terms of transportation costs, Skyway boasts significantly lower figures compared to rail, automobile, and magnetic suspension trains, achieving up to an 1,800% cost reduction over traditional monorail systems. The total estimated cost for projects like Skyway is around $300 million, as exemplified by a specific project mentioned in the Miami Herald. Additionally, Skyway's implementation requires minimal leveling or mountain drilling. The Airspace Cabin Vision 2035 Plus is Airbus's proposal for future airplane interiors, aiming to improve both passenger experience and operational efficiency. This vision includes biometrically enabled smart seats, individual climate control, and state-of-the-art in-flight entertainment systems utilizing virtual and augmented reality. A wide range of cabin configurations will be available, from luxurious suites to economical classes, with flexible designs to meet passenger demands. To enhance comfort, the design incorporates features such as ample overhead bin space and improved lighting. To reduce its environmental impact, the cabin uses eco-friendly materials and energy-saving features. Substantial investments in research and development would be required to build such a cabin, though the exact cost is unknown. The EHang 216, designed by the Chinese manufacturer EHang, is a two-seater autonomous electric vertical takeoff and landing (eVTOL) aircraft. Also referred to as the EH-216, this pilotless passenger-carrying unmanned aerial vehicle focuses on urban air mobility and demonstrates cutting-edge technology. The pricing of the EH-216 is $410,000 for global markets outside China. Within China, the suggested retail price is 2.39 million yuan, approximately $338,000 in American currency. The strategic pricing aims to make autonomous aerial transport more affordable and realistic, advancing the commercial viability of eVTOL technology. Virgin Hyperloop aims to transform transportation by rapidly pushing passenger or freight pods through near-vacuum tubes, combining electric power with magnetic levitation. These pods can travel at speeds of up to 670 miles per hour, drastically reducing travel time between cities. The goal of Virgin Hyperloop is to reduce the normally 6-hour drive time between San Francisco and Los Angeles to 30 minutes. The business's ultimate goal is to create a safe, efficient, and environmentally friendly transportation option that significantly reduces travel time and pollution. As the system is still in the planning phase, actual passenger pricing is not yet available. However, estimations indicate that it might be priced competitively with current airfare and high-speed rail options. Regulatory clearances and the effective deployment of the technology are prerequisites for the anticipated launch of passenger services in the 2030s. Bellwether EVT is an innovative electric vertical takeoff and landing eVTOL aircraft developed for use in urban areas. The Bellwether EVT is popularly known as Volar. Its wingless lifting body and concealed propulsion mechanism make it an excellent choice for urban settings, redefining intracity mobility. The Volar is small, eco-friendly, and provides a smooth transition between ground and air travel. The third-generation Volar, the ORX, offers enhanced flight efficiency and reliable performance in complicated urban environments thanks to innovations in airframe design and flight control technology. The ORX exemplifies Bellwether's dedication to developing innovative aircraft with a focus on human needs. It can accommodate 3 people and measures 3,700 by 6,300 by 1,900 millimeters. The price tag will likely start in the 7 figures, but as manufacturing gets more efficient and scales up, the hope is that it will converge with the cost of owning a car. The Avant Solo electric sports car personifies one-seater urban mobility. Designed with an eye toward making an electric sports car's cabin more interesting and entertaining, the project began in 2020 as a partnership with Coventry University. For the lone traveler seeking an unforgettable experience apart from the typical internal combustion engine vehicle, this electric marvel provides all the power you need without the vibration and noise. Thanks to its small size and nimble handling, it can zoom through city streets. The Avant Solo's electric engine produces 56 horsepower, allowing it to attain a maximum speed of 129 km per hour. On a single charge, the 17.4 kilowatts battery pack guarantees a range of up to 160 kilometers. At a starting price of $188,500, this revolutionary electric sports automobile is affordable for eco-conscious individuals who want to make a statement. Plana eVTOL aircraft is a hybrid electric vertical takeoff and landing eVTOL plane being developed by a South Korean firm called Planero. They hope to make regional air travel more accessible with their hybrid air taxi, which has an impressive range of up to 500 kilometers and is priced affordably. This will revolutionize urban air mobility. When compared to completely electric vehicles, Planero's hybrid propulsion system improves fuel economy and increases range. If all goes according to plan, the business will supply Sky Taxi with 10 CP-01 planes by 2030 and another 40 by 2040. It is said that Plana is trying to make it cost-effective by scaling manufacturing in an effort to bring the price down to $3.5 million. However, the precise current pricing is not disclosed. Plana is aiming high with its ambitious objectives, which include creating full-scale prototypes and achieving mass manufacturing with the help of substantial fundraising. Kekona aircraft represents an innovative category of electric vertical takeoff and landing eVTOL aircraft specifically suited for public transportation. It is being developed by Kelowna, a startup company based in New York City. The airplane, frequently referred to as a drone bus, has the capacity to transport 40 passengers in addition to the pilot or even 10,000 pounds of goods. The 8 thrust vectoring fans and variable pitch propellers it possesses allow it to optimize each stage of flight for maximum efficiency and performance. The first route that Kekona intends to operate will consist of a trip from Manhattan to the Hamptons. The journey will take around 30 minutes and will cost $85 per person. Even as the technology continues to progress, future paths are still being considered. Battery capacity will account for an astounding 80% of the vehicle's overall weight, which is more than 13,600 kilograms. In 1979, Rockwell International began developing the Star Raker, a spaceship that would carry heavy payloads and go from stage 1 to orbit using a combination of ramjets and rockets. This remarkable winged orbital launch vehicle was engineered to land horizontally and take off horizontally. The Star Raker was an ambitious spacecraft that hoped to drastically cut the anticipated $22 to $33 cost per kilogram of payload to orbit in 1978, reshaping the space transportation industry. The intricate design, which had 225 pieces, had proportions of 22 by 66 m and had the potential to be cost-efficient. The Star Raker had a useful purpose as a spacecraft but also served as the basis for many fictional representations and replicas. The Star Raker is an important character in stories about space travel, both real and imagined, because of its ingenious aircraft engineering and its cultural impact. NASA's Capstone is a small CubeSat mission called Capstone, which stands for Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment. It was launched by the National Aeronautics and Space Administration to verify and assess navigation systems and lunar orbit dynamics that are vital to the Artemis program. Approximately $30 million was spent on developing the Capstone spacecraft, which is roughly the size of a microwave oven. The mission's development cost $13.7 million, with an extra $9.95 million going toward the launch. Rocket Lab's new launch pad in Virginia allowed the mission to take off, thanks to the launch contract that NASA granted to the company. Both NASA and taxpayers have benefited from the mission's use of fixed-cost contracts, which have effectively reduced costs for the Lunar Gateway and subsequent trips to the Moon. The Capstone mission will serve as a demonstration of precise navigation systems. NASA's HAVOC High-Altitude Venus Operational Concept explores the feasibility of human exploration of Venus. HAVOC envisions an evolutionary exploration plan focusing on the atmospheric conditions of Venus, which present a more manageable environment compared to its hostile surface. The concept includes using crewed airships to float in Venus's upper atmosphere, where conditions are more Earth-like, enabling scientific research and potential future colonization. A detailed study on this atmospheric habitat was conducted by Dale Arney and Chris Jones at NASA's Langley Research Center. Various models and artworks related to HAVOC are available, such as a 3D model of the HAVOC crew transfer vehicle priced at around $35 with discounted offers available. Additionally, a softcover publication on HAVOC was listed at $134.75. Artworks related to HAVOC missions can also be found priced at $15.